My dear students and learners, this is my sixth video about thermodynamics, and now after crossing the basic concepts and fundamentals and zeroth law, now we have entered into first law of thermodynamics. And in the last video itself, it was told about the first law of thermodynamics is talks about the energy conversion. So this first law of thermodynamics is a special case of law of conservation of energy. That is, energy can neither be created nor destroyed. It is always conserved. Conserved means it is always a constant value. However, it can change from one kind to another kind. That we all know already, we have studied in our schooling. First law also talks about this law of conservation of energy only. That is, all the energy goes into the system will come out as work. That is, the forms of energy has been changed from heat to work. Energy does not vanish, and it has the capability or ability to be converted into any forms. No machine can produce the energy without the corresponding input or expenditure of energy. Okay. That is, energy cannot appear from nothing, and nothing will be converted into energy. Okay. Energy cannot appear from nothing, and nor it can convert into nothing. If it is one type of energy, means another one type of energy will be created, will be converted. Okay, it will not go anywhere. This only talked in first law of thermodynamics, and we can apply this first law of thermodynamics for in two types of descriptions can be have. First one is this first law of thermodynamics for any process. In another term, for the same law is for closed, that is cyclic process. For any process and cyclic process. Okay. What is cyclic process? Cyclic is nothing but the sequence of processes in which the initial and final conditions are identical. Okay, initial and final conditions are identical. Okay, so here this form equation, this shown equation del u is equal to du equal to del q minus del w is talks about the first law of thermodynamics for any process. If a process is happened, then the heat supplied and the corresponding work done, corresponding conversion to work done, the difference between that heat supplied and the work given to the system will be stored into the system as du, that is change in internal energy. The heat supplied into the system will be transferred to first stored energy, and then remaining part will be converted to work. Okay, and then for you can say that if it is for a cyclic process, then we can say that cyclic integral of del q is equal to cyclic integral of del w. A system is taken through a cycle of processes so that it returns to the same state or condition from which it started. The sum of the heat and the work effects will be zero. Cyclic integral of del q minus del w is equal to 0. Okay. 0 means it is a point function. A property which is stored inside the system is a property which is called the stored energy. Okay, we can also prove by the derivation that the energy, the stored energy is also a property of the system. Okay, cyclic integral of del Q is equal to del W is for cyclic process, and here du is equal to del Q minus del W is for any process. Okay. Corollaries of this first law, that is, we can change the form, or we can have so many meanings for the same this law of conservation of energy or the stored energy present in the system. As first corollary 1, we can say that when a system executes a process, the net heat interactions equals the net work interaction plus change in stored energy, that is del Q is equal to del W plus du. Okay, we can say when a system executes a process, the net heat interactions equals to the net work interactions plus the stored energy. Again, we can tell it as there exists a property of a closed system such that changes in its value during any change of state is given by the difference between the heat supplied and the work done. Okay. Corollary 2, we can say that for any isolated system means here we can say the this is the best example for a cyclic process, that is whatever the energy inside our universe is inside the universe only, we are not going to keep out or throw it out or get it back, right? For an isolated system, both heat and work transfers are absent. Del Q is equal to 0, del W is equal to 0, that's what the dE is also 0. Then if you do the integration of dE, which is equal to 0, means then E equal to constant. That is, the energy of the isolated system is always constant. Okay, energy. So that's what energy is constant only. He is told us energy cannot be neither created or destroyed. Okay, again, perpetual motion machine of first kind. Third corollary is, we can take it as PMM1. What is this PMM1 is a machine which does not follow in the first law of thermodynamics. What we are saying in first law of thermodynamics is, if one energy is there, then only it can be converted to another form. If there is nothing, no input, but continuously if you are taking the output, means then the machine is called perpetual motion machine of first kind. That is, without absorbing any form of energy, a imaginary device which produces a continuous supply of work, or it is if it is given to the surroundings, or such a machine, if it creates energy from nothing, from no supply of any sort of energy, means then it violates the first law of thermodynamics. Then it is called perpetual motion machine of first kind. Despite several attempts have been taken to invent such a machine, that no input but continuous output, but no device has not yet invented. Several attempts have been taken but not yet invented. It is not possible also. If you take food, then only you can work, right? Or if you don't take food for 1 week, the stored energy inside our body, fat, will help you to work to some count of days only. It is not possible to have the output without input. You can check it out. This is the spontaneous process. Whatever we are studying in thermodynamics is all are explained, which is studied by the nature. Spontaneous process means naturally created processes. So heat will always flow from higher temperature to lower temperature only. Water will flow from higher altitude to lower altitude. You cannot change it. If you want to reverse the processes, get the reversed direction means you have to supply our energy, created energy. You have to spend the power to get the reverse direction for the spontaneous processes. Okay, so first law of two types of first law of thermodynamics and three corollaries for first law of thermodynamics. This is the equation in which the internal energy has come into play along with the first law of thermodynamics. Okay. Now, gas laws. Why we are studying this gas law in the thermodynamics is all types of any solid, liquid and gaseous substances, fluids, when it is supplied with the heat energy, they are converted into, they have been transferred into gaseous state to get the higher energy, higher level of energies. It has to be heated more, and there will be finally we are getting the vaporized form of all sort of substances, and how that gases are acting, affecting or working inside the thermal devices are only going to be studied in thermodynamics. So what are the behaviors of gases, how they are acting, what are the various properties, characteristics, how they are giving the work, how they are observing and storing and rejecting the heat energies, how they are converting that heat energy into work energy, absorption, storing and then rejecting the various types of energies by gas substances is only studied in thermodynamics. So it is very important to learn gas laws. Okay. Already you come across what is perfect gas, real gas, and various gas laws, everything. But now we are just going to recall the gas laws. Okay. So you know Boyle's law, Charles law, Gay-Luccas's laws are the very important basic fundamental laws which tells and gives the final version of PV equal to RT. That PV by T equal to constant or PV equal to MRT. Well, you know various versions or various forms of gas laws. Okay. So Boyle's law, we are keeping temperature as constant. In Charles law, P as constant, and Gay-Luccas law, volume as constant. And by conducting the experiments by keeping these characteristics or properties as constant, and other two properties are being monitored, what happens to other two properties, okay, is only studied in this Boyle's law, Charles law and Gay-Luccas law. Okay, so Boyle's law, PV equal to constant, Charles law, A by T equal to constant, Gay-Luccas law, P by T equal to constant. Okay, then types of thermodynamic processes. Okay, we have seen the types of states, types of systems, types of boundaries, types of heat transfers, and various kinds of processes, etc. So here various types of properties, everything was studied. Now I told in the last slide, we are keeping or conducting the experiment by keeping any one of the property as constant, right? Okay, look at here how we are conducting the processes. Especially here we are studying thermodynamic